Good morning again for those who just joined us. See, we're 3 minutes after. That's probably good enough time. I'll allow people to trickle in. So welcome to our final round of career intern presentations. We have our final four, last but definitely not least, presenting today. Before we get started, I just want to give a little overview of the program for those not familiar. The Career Internship Program has actually been running for a very long time. When we were UNAVCO, it became an official program in 2015, and then when we became ERSCOPE, it became the ERSCOPE Student Career Internship Program. And the purpose of this program is to provide students with a real-world work experience. So typically, this is undergraduate students, graduate students. I just realized my slides aren't going. So a real world work experience. So we take undergrads, grad students, and recent graduates. Not a lot of opportunities out there for recent grads, so we feel proud that we're able to offer that. And the biggest difference between the Career Internship Program and the Recess and Geo Launchpad is that they're not necessarily doing research. This is kind of based on like coming in and really seeing what a job is like, what working for a facility like ERSCOPE is like, and contributing to the work that we do. And each intern is funded by the directorate. And so this year we had interns, we had started with interns in every directorate. Mostly we have a lot of interns in the engagement side because I think that we're just very familiar with the program, but we would love to see this expand. But the students you'll be hearing from today were in engagement, and Marc also helped on the data services side, which is fantastic. And so let's see. Typically, this program runs over 11 weeks every summer. They are remote or in-person options. So everyone on the call today worked remotely, but we did have one career intern that we heard from last week who worked up in Alaska in person with Ryan Bierma and field engineering work. We did a whole week that actually kind of spilled over, I think, into a couple of weeks of orientation activities. So really getting them talking to the VPs of each directorate, learning more about ERSCOPE. They met Bex, and doing some team building stuff, getting to know each other kind of thing. We really tried to build some cohort, even though we were all remote, which as everybody knows, it can be challenging, but I think we did an okay job. And what we really hope for is that these students will become integral members of the team. And so they are participating in staff meetings, hopefully meeting other staff and feeling like they're part of the team and really learning and seeing what it's like to be on the team. They were given the option to attend the professional development workshops that Anika and I lead for the Recess and Geo Launchpad interns. And it's great to have them join from time to time. A lot of times the career interns are a little bit further along than our Recess and Geo Launchpad interns. And so to have them come in and kind of share some experience and give advice and what's working for them and not working for them has been really helpful. And then at the end of the summer, they give a talk, which is why we are all here today. We are looking at revamping this program. We've kind of surveyed a few of the staff members, talked about what needs are. These are kind of the things that have come up, and this is what we're hoping we can get the program to one day. Maybe having career interns not just in the summer, but at any time during the year. Non-science positions are great. We would love to offer FAB interns or HR interns or anyone that wants an intern should be able to have one. We had a great meeting planner intern that you'll hear from today, who was a non-science position. And we would really like to see these interns go, into an ERSCOPE staff role if that's their goal. We spend a lot of time getting them introduced to ERSCOPE, training them on our tools, getting them to know kind of what we do. And so all that time and money spent would be great if we could then offer a position to have them formally join the team. And so we're working on that. We would love to see career interns possibly at the EPIC. And so with that, let's go back to our first slide here. So we're going to hear today from first from Marc Garcia. He was an on-ramp to the cloud intern with Tammy. And we'll hear from Angie, who did meeting planning with Kristen. We'll hear from Anne, who was an educational data and resources intern with Beth. And then Ellie will round us out on her experience with the that's such a hard one, isn't it? The seismological skill building workshop, where she was a teaching assistant and evaluation intern with Michael. So with that, I will stop sharing. And Marc, you are welcome to take it away when you can.
Thank you. Okay, is my screen showing? Yeah, okay. Everything looks good? You guys can hear me? All right. Well, hello everyone. I'm Marc Garcia. I was this year's on-ramp to the cloud summer intern. My mentors for this summer was Tammy Bravo and Tim Dittman, and this project was funded by Earthscope's engagement services. So a little bit about me. I am a PhD student at UT El Paso. I actually defend my candidacy next week, so really excited for that. Some of my research interests revolve around seismology, data science. I do machine learning, Latin American tectonics. So right now my dissertation is focused in the Mexican subduction zone. And I also do a little bit of science communication education. I love working with middle schoolers and high schoolers doing earth science activities. It's always really cool to see their smiles and they get excited when you give them things. My future goals, I hope to be involved in data science and seismology. I don't think academia is really for me. I would like to hopefully be in a position either at a national lab or a company like Earthscope. And once all that is over, hopefully I retire rich and I can just become a goat farmer for the rest of my life. Um, and then the picture here, I got to present my research this summer. I got to go to Costa Rica in July got to visit a volcano, which was really, really cool. I didn't have any field photos or any working photos of what I did this summer because I was just on my computer, but this is a little bit of what I experienced. So going into kind of what the role and my expectations were for this summer. So the internship role really was focused on enhancing the accessibility of Earthscope's new Jupiter Hub environment. And this meant really going into developing user-friendly documentation, how to use the infrastructure, contributing into some notebooks, so giving people a landing page, and then just overall just finding ways into enhancing users' experience in the Jupiter Hub. And really, its target audience for right now is geophysicists, geoscientists, educators, and any student who wants to use and leverage the cloud resources for their research. Personal expectations for the summer was really enhancing my technical skills. So either learning cloud computing and working on my Python skills, learning cloud computing and its architecture. I don't really have a big background on that, so it's interesting to be in a team. Experience working with a development team or just a team in general. I think it's really good to understand collaboration, especially on a company like Earthscope. Building professional networks. So I got to connect with a lot of people this summer, got to meet a lot of people, and then really just gain industry insight. I've never worked with a company like Earthscope before, so it was really interesting to see um, the day at Earthscope. So a little bit of overview of what On-Ramp to the Cloud is. So the whole goal of this is really to build a foundation for research through research and education through cloud transformative science. And the big motivation to move to cloud systems is really to gain reliability, scalability, and equitable access. So it basically gives any user around the world, as long as you have internet connection, you are able to use these services and these tools to really enhance your experience using Jupyter Hub. So the GeoLab Notebook Hub itself uh, works a little differently. So there's really two parts to this cloud system. One being the migration into data services. So we're pulling Sage Engage data into the cloud, and that's being hosted by Amazon Web Services. And then GeoLab itself is just a Jupyter Hub where you can spawn Jupyter notebooks. And for the user, that's probably where most users are going to spend their time in. And that's all web-based. And yeah, this platform is really designed for community use. It benefits education and community and research. So it's a really, really good initiative. I would like to note this is new. There hasn't really been a lot of effort or yeah, this project is fairly new. So coming into this project was interesting to really not have a lot of background in it and then just kind of building everything from scratch, which was challenging at times. So kind of the first goal that we set out for my internship was developing some intro documentation for GeoLab. So the first one I created, and this was all done in a notebook format. So once you log in into Jupyter Hub, you can pull up Jupyter Lab, open up these notebooks, and you can read through the documentation. First one I made was a welcome to GeoLab, which is kind of the nitty-gritty details of what it is, how the system works, what different definitions as far as images, Docker containers, Docker spawners, things like that, why we use notebooks and where the data is stored. And then the next one I created was a how-to notebook. So this one is just an introduction on how to use Jupyter Notebooks. So if you've never used this, it just runs through the basic functions, the widgets, how to run, how to save, move cells, things like that, how to do basic coding, how to open up a terminal. I know that's always really a big struggle. And then the next one was something that we now developed was a guide for early adopters and contributors. So those who are interested in both bringing in their short courses or becoming a researcher, they can kind of go through this and see what we are expecting for at least on this Jupyter Hub. And then an overall, just the getting started, how to log on, how to choose your server, things like that. So this summer we were able to run the first course on the Jupyter Hub environment. It was MS Pass in mid-July. Overall, this course went surprisingly smooth. I was in charge of both helping test all the notebooks, helping students around through questions, and as well as participated in it. So I did learn a little bit about parallel processing and running seismic databases, which was really cool. There was really no issues into this Jupyter Hub environment. The only thing that was lacking was a little bit of documentation. So students were picking wrong images and things like that. But overall, it was a really good success. If you guys want to look for more details, you guys can read this article that was published. The second goal of my contribution was developing notebooks. I don't know exactly where this is going to live. Hopefully it'll be in the environment where researchers and educators can come in, kind of put their own notebooks and users can kind of pick and choose what they want to look for. I chose something that I was familiar with. I do a lot of earthquake detection. So the first one I did was leveraging a machine learning toolbox SeisBench. Did a simple earthquake detection using a network in the Pacific Northwest. And that really just shows the power of the cloud system. I was able to process a lot of signals and stations. And then the next one was just kind of an introduction to signal processing, so filtering, um, spectrograms, and then also kind of using another machine learning denoiser, which was really interesting. And all these notebooks can be found in our Earthscope GitHub environment. So some challenges and takeaways this summer. Big one was really understanding the cloud architecture. As I mentioned before, I didn't really have any prior knowledge to that. Learning how to become a developer and document code effectively, that was definitely a big learning step for me. And then understanding developer tools. So I have had a little bit of experience with GitHub, GitLab, but definitely diving into that was good. I feel like I improved my documentation skills. My remote work experience was really good. I didn't have no issues. I felt really involved in all the meetings. And then I definitely increased a lot of my technical proficiency. So whether it was in the developer tools or with scripting languages. The Future for GeoLab, there is an upcoming short course in October, the MT short course. Um, Hopefully that all goes well as well. And then hopefully moving the seismology skill building workshop onto the hub. That'll be really interesting to see. Bringing in more early adopters, getting the cloud services, up and running where we can have direct access to data, and then really just bringing in more short courses, whether it's in machine learning in my realm or any other aspect in Sage or Gauge um, facilities. And with that, I end my presentation. If there's any questions for me, a really special thanks to Tammy and Tim. It was a really great summer. I learned so much, and everybody involved in the team and my fellow interns for all their support. Thank you.
Great work, Mark, and presentation. Anybody have questions for Mark? Shelley?
Hi, I know, really great presentation and so awesome to see um, having some of these basic materials for cloud and cloud computing. Um, so Mark, if you're like walking across campus and someone says to you, "What's this cloud computing thing?" Um, how do you describe the cloud?
I think there's several aspects to the cloud. In a basic explanation, I would say it's really being able to run a different computer on your own computer, and that computer can basically be as big and as powerful as you want it. That's how I would explain it. So you're not really relying on your own computer's processing power or memory. You're really just running things elsewhere, and that's why it's not necessarily up in the sky, but it's just another computing place elsewhere that you can directly access through the internet.
Awesome, thank you. And that was not a test. It's more like, you know, I'm thinking about like walking through my little hometown. It's like, yeah, we do cloud computing. What the heck is that? And depending on their age level, I choose different terminology.
Yeah. Yeah, it's always
Thanks.
hard to really communicate, especially technical science. I struggle with that with little kids. That's been the hardest question I've ever got is explain my research to a couple third graders.
Yep. Yeah, it takes practice. It
Yeah.
sure does. Thank you.
Yeah, thank you.
Michael?
Thanks, Mark, for the presentation and for your work this summer to help, get the hub up and running. I guess one of the questions I have from your perspective as a PhD student, how do you see the hub fitting into the work of your, research or your peers' research going forward? And maybe a second part of that, is there a fit for the education portion of your PhD work for the hub? So we've run short courses ourselves out of our scope, but is there a role for classes and whatnot in the hub?
Hmm. Yeah, well, I mean, first and foremost, I've done a lot of machine learning in my PhD work, and that training those models require both memory and data. So definitely there is an advantage of having direct access on a cloud. I mean, you're being able to access a limited, unlimited amount of data, which would be really interesting to see if some developer wants to, train models, things like that. As far as the educational side, one thing that we did learn from the short course is just being able to have the same computer, the same setup as the instructor just makes things really easy to follow along. You're just able to run cells and nothing breaks. And you're like, oh my God, I don't need to download this and run around looking for things. So on the educational side, I think it really benefits to just have the same environment as whoever's presenting their work. Um, and yeah, I mean, there's a lot of cool benefits to this new hub.
Great, thank you.
Yeah, thank you.
Awesome work again, Mark. Thank you.
Thank you.
Next up, we will hear from Angie. Angie, take it away.
Hello, sorry, let me pull it up. Sorry, let me just make sure it goes back and forth. Perfect. Okay. And then everyone can see it, correct? Right?
Yes. Yep.
Okay. Hi, I'm Angie Pena, and I was the event and meetings intern. A little bit about me. I'm a little bit different, as Kelsey mentioned before, but I'm not a STEM or science major. I recently graduated from San Diego State University this past spring, and my major was hospitality and tourism with an emphasis in meetings and events. I've had 3 years of experience in the hospitality industry throughout my college career. And fun fact, I recently did a study abroad in Korea. These pictures, the first one is a really big project that I did at the end of my last full semester at SCSU, which was hosting basically an event that we pitched to the city of San Diego and my graduation pic and me in Korea. So a little bit of a summary before I get into what I exactly did throughout this summer. I got to see the different stages of event planning, which I'll get into later on in the presentation. I sat in a bunch of different meetings and calls with Kristen and other staff, such as like post-event calls, finance meetings with FAB, updating contract calls, scheduling to see what was upcoming events. And overall, I got to help plan and organize events alongside Kristen. This is a timeline of all the events that I worked on throughout this summer, starting off with the Intern Welcome Week, this 2024 Sage Gauge Workshop, the Geophysics Field Instrumentation Education Workshop, the Machine Learning and Subsurface Geoscience, and lastly, the MT Short course. Starting off with the Internship Welcome Week, I didn't really get to work on it while it was going on. I worked on mainly the post part wrap of it. So the Internship Welcome Week was a 25 attendee event. It was in person and it was hosted at Albuquerque, New Mexico. And since the event already took place, I got to hop in on some post-event wrap-up calls and got to see how everyone discusses what went on during the internship week, what went well, the feedback they got from the interns, and I got to basically sit in on those calls and report back to Kristen and to talk about how that went. Moving on to the 2024 Sage Gauge Workshop. It was more of a larger scale event, but it was virtual. It was a 221 attendee event. It happened in June and it spanned between two different sets of dates between 2 weeks. This event was already contracted and set in stone when I hopped on. I just got to work on the end cap of it and worked during the event. So I was tasked to help make the welcome packets for the attendees that wanted to receive those. And I got to make a bunch of spreadsheets, and send them over to Kristen to see who wants the spreadsheets. And then throughout the event, I got to help work on the pre-workshop short courses, the plenaries, and the SIGs. And I just sat in on all of the Zoom sessions, or most of the Zoom sessions, to monitor any technical issues that may occur, any questions, or any attendee issues that might happen. And then on the side here, we have my little Excel spreadsheet. And then at the bottom, just a screen cap of the start of the event since it was virtual. Next, we go into the Geophysics Field Instrumentation Education Workshop. This one is actually happening currently. It's a 40 attendee event and it's in person and it's happening in Golden, Colorado. This one was already contracted, so it's already in progress, but I got to work through the middle of it and the end. I did sit on a couple meetings with Beth and Kristen about this, and I got to work on the catering menus for the attendees. I really don't get to experience working on larger catering menus with the experience I've had in the past. So this was a little bit fun seeing all the challenges that I can do with this, with dietary issues and the larger scale, like more days and like planning out breakfast, lunch, dinner. My catering menu document is a little bit extensive, so I only put 2 pages of it on the side over here, just so it doesn't take up all of the screen. And then next is the machine learning and subsurface geoscience workshop that's going to be happening. This one's a little bit on a pause right now, but with what the information I had, this is what the event is going to be like. So it's an 100 attendee event, more of a larger scale event. It's a hybrid event, and it's going to be taking place at the Los Alamos National Lab in January 2025. I got to see a little bit of the pre-contracting phase with this and all the communication that went on to get the event started. Unfortunately, since it's on a pause right now, we're working with what we have. So I was tasked to look for a housing and meeting and venue space for the attendees in the Los Alamos region, which is a little bit difficult because I don't really know this area. So, and there's not a lot much to do over there. So seeing and trying to find an event space for near this venue was very interesting. And then next, as mentioned before from Mark, we have the MT short course, which is happening in October, and it's an in-person event with about 25 to 30 attendees in Socorro, New Mexico. This one was a little bit of a pre-contracting slash it was already in the talks contracting. What was nice was they already had a preset location and event space. So what I was tasked to do was starting a contracting process for a hotel block, which is basically just blocking out a bunch of hotel rooms for the attendees. What I've learned throughout this internship, I've listed a bunch of things over here, but I'm just going to talk about it. So professionalism skills, I feel like I gained a little bit more professionalism coming out of this internship. I had to send a lot of emails out, and usually that's not my strongest suit with professionalism. Sometimes I feel like emails are very hard to plan out, and sitting on a bunch of different calls with a bunch of different people, I got to network and connect with a bunch of different staff throughout Earthscope, and I feel like that builds a lot of professionalism when they're asking you questions. And then being detail oriented, it's something about I feel like a lot of people don't know about event and meetings planning is that you really need to be like honed in on all of the details for planning out something, especially like agendas and catering and housing, because if you don't have all these details and they all fit like in a puzzle piece, and if one puzzle piece doesn't fit properly, you'll see the repercussions of it like later on, and you really need all of those puzzle pieces to click in together. So being detail oriented as an event planner is very big. Communication, I talk about this in the next slide, but communication for remote planning, I feel like is a different ballpark that I didn't even know that much about. So I got to learn more about communicating through the remote side, and then the different phases of an event. So we have like the pre-contracting, the contracting, the prep for the event, the kickoff for the event, and then post-event wrap-up. What was surprising to me was I was mainly in-person event attending and planning before this. So the virtual side, I was very not aware of before. I got to see a brief part of it due to COVID, but mainly I wasn't on Zoom that much. So seeing how Zoom is incorporated into virtual events and hybrid events compared to in-person, I very much am a face-to-face person when it comes to like this event planning and everything. So it was a little bit different and difficult not seeing in front of me, like, and picturing my event space or seeing like the area or being on site. And especially communication with this is a very large aspect of it. I like all the emails that got sent out and like sitting in on different calls. Usually I'm like a face-to-face, like let's have an in-person meeting. So this was it's like a contrasting difference between what I'm used to. And some concluding thoughts is that overall, I think it's a good experience to see the remote side of event and meeting planning. I know you do go in person sometimes, but mainly throughout this summer it was mainly remote. And it's so diverse because you have like virtual still, you have hybrid, and you can still do in person. And seeing the business aspect, I usually am on the social, like casual events meeting side. So seeing like more science and business aspects was refreshing for me and more building in my skill set. And lastly, these are some people I like to thank. I like to thank Kristen the most for helping me throughout this whole summer and being a good mentor, and the event staff, and Kelsey and the rest of the Earth Scope staff. Thank you.
All right, Angie, very good job. Lots of work done, lots of new experiences, which is great. Questions for Angie? Michael?
So Angie, maybe a little less of a question, but more of a thank you. I think it's important to highlight the work that goes into these things. A lot of us on the operation side of things are, used to dealing with running meetings, attendees being there and that sort of thing. And there is so much that happens behind the scenes that the meeting planners take care of. You definitely seem to have gotten your feet wet in figuring out what that all looks like from a whole different bunch of angles, right? From contracting through catering and all that sort of thing. So I guess maybe I would, you talked a little bit about the virtual side of things versus in-person meetings that you had more experience with before. So I think maybe my question is around that virtual aspect. And I wondered if you came away with either new ideas for virtuals, things that should be done, or things that shouldn't be done based off of your experiences over the summer.
Yeah, so with virtual, I feel like I have a more greater appreciation for it. And I did learn a lot of things that I should do, like starting from now. Virtual events in the hospitality industry is still very, it's still prevalent, but not as prevalent anymore. It's more like oh, this is the last option that we will go to. So I feel like now that I have more of an experience, like how a virtual event can be ran, I feel like in the future, if I ever like get to a point where I can suggest it as like an option, because honestly, I think hybrid still is a really good option for events, especially to reach out to a broader audience. So I feel like suggesting hybrid more so than completely virtual is an idea that a lot of meeting and event planners should consider in the future. It is a little bit of a setup because I have had a little bit of experience in more hybrid than completely virtual. But I think it's something good to keep in mind from moving forward in this industry.
Great, thank you.
Great work, Angie. We really appreciated everything you did. And good job, Kristen, too. Okay, so next we have, I think it is Anne.
Okay, thank you.
Yeah. Take your time.
Can everyone see my screen?
Yep, looks perfect.
Okay, great. Thank you everyone for coming. My name is Anne. I'm one of the 2 educational data and resources interns along with Katri Spencer, and we were both mentored by Beth from the Engagement Directorate. A little bit about me. I am a PhD student at Northwestern University where I study seismology. My research mainly focuses on applying machine learning methods to seismic data in really noisy urban environments. I never really thought too much about opportunities in education until very recently, wherein I had some really incredible teaching assistant experiences, and I also got to organize a high school internship program called NU Geopaths. and I found that really rewarding. So I wanted to explore the educational field a little bit more, which is why I applied to this internship. But as a one sentence summary of what I did over the summer, I reviewed and updated Teach the Earth materials available on CERC, which is the Science Education Resource Center at Carleton College. If you're not familiar with Teach the Earth, it's a collection of thousands of resources for geoscience instructors. A lot of these are modules that provide instructors with PowerPoint presentations, exercises, assessments, and their answer keys. So really everything you need to run like 2 to 5 lab or lecture sessions. And there's a really wide variety of content available on Teach the Earth, which I got to get a glimpse of by working with very different types of data and very different geoscience disciplines. But for this presentation, I'll focus on seismic refraction, which is the module that I spent the most of the time on over the summer. So this module is called Measuring Depth to Bedrock Using Seismic Refraction. It's a module within a larger collection called Iguana, which introduces students to geophysics for urban and near surface applications. And as a little overview of this module, the module introduces students to the concept of seismic refraction, which, if you're not familiar, refers to how seismic waves bend when they encounter different subsurface layers or properties. So here in this simple example, you see a seismic wave that originates from a source. It could be an explosion or a hammer blow, and it travels through the soil layer. And when it meets this bedrock layer, it kind of bends and then moves along this boundary and then moves back up to be detected by these line of sensors, which are called geophones, and you can see a picture of them here. And so by using geophone data and detecting these refracted waves, you can infer subsurface properties like depth to bedrock, which is really critical for any sort of engineering or environmental project. So it also showcases to students like the types of jobs you can have with a geoscience degree. So after you learn about the theory of seismic refraction, students can then either analyze already collected geophone data, or they can go out into the field, request instruments from the EarthScope Primary Instrument Center, and kind of hammer onto the ground and collect their own data, which is pretty cool. If you're not familiar with this module, you still might be familiar with this concept because it's very popular in a seismology or geophysics class, because it allows students to engage and connect with these big aspects of geoscience like theory, instrumentation, data analysis, and societal applications. So to talk about how I contributed to this module, kind of go through the typical workflow of an instructor that prepares for this type of unit. So the first thing you would need to do is kind of provide background material and exercises on the theory of seismic refraction and also the instruments that you use. And in this regard, I did a lot of revision of some existing material, revised some Excel-based exercises that's available on the module. I also added alternative text to all figures so that the modules are more friendly to people with screen readers. So these were a collection of like small changes here and there. And then is like the next step, which is like probably the most demanding step. And this is if you're collecting your own data, you would go out into the field, set up your equipment, and you would acquire your own geophone data. And this is really demanding because there's a lot of moving parts, lots of cables to connect. So I actually got shipped this like massive 50-pound shipment to my house, which I had to drag up like several flights of stairs, and I had to kind of test it myself. And so in doing so, I updated some existing equipment documentations that's available through Epic. And I got to add more instructions, recommendations, resources, and also modify the instructions so that it adapts to current best practices. So that was a big chunk of my summer. And then after the step, you go back into the classroom, or your instructor goes back into their office and then does some data processing, because initially your geophone data will look something like this, which is a little overwhelming to work with. And so you have to do some zhuzhing and make it look like this, which you might be like, that still looks really terrible. But at least in this picture on the right, you'll see students can more easily see the first arrivals of the seismic waves from the hammer blow or the explosion. And so this particular stage has been usually done by the instructor, because thus far the software option that we've provided called Pickwin is a commercial software. I actually worked with the module author Angie Pena to create a Pickwin guide to go into the module and also through Epic. But because it's a commercial product, it does come available through the Epic Field Computer, but it's only available through Windows if you want to download it yourself. And if you don't have a license, you can only launch it 15 times. So that's why this step is usually done by the instructor rather than the student. And so part of my summer, I got to explore some alternatives, and I actually found an open source alternative called RefRap that's compatible with Mac OS, Linux, and Windows machines. So I got to create a completely new guide, kind of walking through instructors and students to install and work with this new software to do their data processing. Unfortunately, it's a lot more demanding than the Pickwin option, so I feel like only a few people might kind of opt for this, but I was still happy to provide an open source option out there for the community. And then lastly is data analysis, where students take, sorry, I have to go back. There's data analysis, where students take this really crazy data, do some math that they learned in step 1, and then infer depth to bedrock, which is about 3 meters here. And it's like a lot of moving parts, but it really comes very nicely, because students then get a taste of what I think is the coolest part of geophysics, which is like you take some crazy squiggly data and you get something meaningful out of it. So I was really happy to work on this module. I got to work on other really cool things over the summer as well, including going to the Earth Educators Rendezvous in Philadelphia and help participate and facilitate a workshop on the community contribution tool. But Kitri last week did a really excellent job kind of talking about it, so I thought I would talk about something different. I got to meet a lot of my goals that I had set out for myself in the beginning, like working with technical documentation, learning how to make activities data rich and sustainable. And I also got to learn a little bit of Adobe Illustrator, which, because I have like really no design background, I was like very easily impressed by everything that I made, and I would show everyone what I did. So this is one of my favorites that I made. But yeah, I had a really wonderful experience, and I'd like to thank everyone who's made it possible, my mentor, Beth, my fellow educational data and resources intern, Kitri, Andrew, Kelsey, and Anika, and all the fellow interns and everyone I engaged with at EarthScope. So thank you.
Nicely done, Anne. We have time for questions. Sadly, Beth couldn't join us today. She's at a workshop, but if anybody has questions for Anne, go ahead, Shelley.
Sorry, took a moment. Yeah, great presentation, and wonderful to see how the two, that your team kind of worked together and still had different goals to do. And so this is more forward thinking, now that you've been working with this kind of module, how is your future like with using coding and modules? Have you Do you imagine yourself like developing any on your own or integrating it into what you do?
Yeah, that's a really great question. I've actually as a TA conducted a similar lab, helped conduct a similar lab for a course I was TAing. So I definitely imagine myself kind of asking if I can like modify that lab a little bit so that it kind of is a little bit more engaging to students so that they interact. Because how we did it in the past was just kind of show a picture of the data and the PowerPoint and just kind of explain it to them there. So I really like for the students to actually kind of get their hands messy a little bit. So I'd like to definitely change some of the TAing stuff that I do. With module development, I'm not sure if I can actually do this because I don't have a background in this, but I think the BFRAP and the Pickwin package also comes with this additional component that allows students to do like travel time inversion and make a more like realistic image of the subsurface. Like now they're just working with a very simplified 2-layer model. So it'd be cool to kind of eventually create like a more advanced module for like upper level students to kind of walk through that inversion process and kind of learn myself if I can.
Yeah, that sounds great. Yeah, thank you.
Thank you.
Michael?
I think you're muted.
In your, thanks, Anne. In your presentation, you had sort of highlighted one of the issues that we often encounter with these sorts of instrumentation, data collection heavy labs, which is, okay, we can ship you the stuff to get the data, but now you have to process the data and you have to go through some work to get it in a format where somebody can work with it. And so I wondered, you had found an open source solution for that. I wondered if if you had considered, or if you think, number one, that there are enough adequate options out there. So I'm not sure how many like solutions you took a look at. And I wondered if you felt like, maybe this is something where maybe the other part of that is often the packages that are available are really robust and do way too much. Like you think about what the user needs to do to get through that lab. They don't need probably 70% of whatever the software options are. So I guess the second piece to that question is, do you think there are options for notebooks to help resolve some of this low-level introductory need for data processing?
Yeah, one of like while I was exploring, one of the options I was looking into is just like using simply, I guess, Python to just like visualize the data, not really download anything else. But then I was like, oh, that really requires someone to have Python familiarity, and that is not always true, or any sort of like programming ability. So there are a wide variety of options out there. But it's like trying to find a GUI that is like easily to do and like an instruction manual that's not more than 10 pages. I was just kind of honestly limited to Pickwin and RefratPy, but I think a notebook would be a really good option. I guess I hear from people that most people just prefer like a click and point. So I think the option of kind of dragging and zooming into a particular area is always really nice, especially in a classroom setting. So, but I think notebooks can also do that. I know there's like interactive notebooks, but I'm not too familiar with it, but it would be interesting to kind of explore that particular option, which I didn't. But thank you.
Great, thank you.
Thank you, Anne. Great work. Okay, Ellie, you're going to take us home.
All right, can we see?
Yes.
Okay, cool. Hi everybody. I think I've met most people who are here, but my name is Ellie. I was a seismology skill building workshop TA and then did some like engagement analysis stuff. So for different workshops and then the short course as well. Really quick, a little bit about me. Like I said, I do think I've met most people. But if you don't know me, right now I'm a graduate student at Tufts University, that's in Medford, Massachusetts. I'm part of the Civil and Environmental Engineering department. So I think a lot of people here are kind of more on the geophysics side or more on the education side. And I've been like in the engineering world, which is a totally different ballgame for people who are familiar with that world. My main research interests are ground motion modeling, site response stuff. but something fun about me is that I'm a former middle school teacher. So I really love the education side of things. And I felt like I've kind of moved through life choosing one or the other. And this summer I've kind of been able to do both, which has been awesome. And then my passions that are not related to seismology are on here. I love sitting on the front porch. If you ever come to Medford, give me a call. We can drink coffee on my front porch. All right, so what I did this summer, I kind of focused on 3 main tasks, which I will talk about more, but as kind of a brief overview. The first one was this seismology skill building workshop, which I hope everybody is familiar with. If not, I can drop a link in the chat after I'm done on more about that. So I was a teaching assistant for that, and I'll talk about what that meant, what that looks like for me day to day, week to week. My second task, I did kind of this syllabus review project and then a research plan moving forward. My third task, I did some data analysis from the seismology skill building workshop and then some short course stuff as well. So I'm going to talk about each of those. So the first task that I kind of talked about is this workshop TA position. And this was a blast. It was really fun to interact with students again. So I kind of had 3 main tasks that went along with this rule of 3s here. And the first one was kind of figuring out like, what is this workshop? So I would go through it tutorial by tutorial and kind of webinar by webinar and figure out like what's actually going on. I've never worked with seismic analysis code really. I'm kind of done GMT stuff, but not really. I'm much more on like the Python, R, and GIS side for things. So I got to kind of figure everything out, which was great. And I learned so much in this process, which was very cool. So I went through the tutorials, made sure I knew what was going on so I could help students. The second piece of this was actually helping the students. So we have this massive Slack like page with all the tutorials, all the students. There's over 1,400 students this summer, which was crazy. It was very cool. So I was working through tech issues, working with the OSL team up in Alaska to try to figure out how to solve issues for students, and then answering actual technical questions about the workshop. So I just have an example here of like a quick exchange on, we had a big OSL tech issue kind of at the beginning of the summer, and working through that was a good time. And then finally, every Monday, we lead webinars for the students. And Jillian, who's one of the main instructors, was out for a few weeks. So I actually got to take over that webinar and do some instructional pieces, which was very cool and very fun. And a totally different experience for me. I've done some online teaching before, but never with a group that size. And I also put together my own webinar on ChatGPT and coding, which was great. We had a nice little turnout of students who were interested in that, and it was just a short webinar on how to use ChatGPT to code effectively and up your scientific computing skills. So that was kind of my first task. My second task was a syllabus project. So it's this research question for an NSF grant that Michael Hibbenthal has been working on. And the question is about optimizing the skill building workshop within the seismology learning ecosystem. And so if you're thinking like, what is that? What is the seismology learning ecosystem? So were we. We were thinking about that as well. So we kind of did a syllabus review of seismology classes and came up with a bunch of concepts as well as a bunch of tools and software that could potentially be used in these classes, and just try to figure out what intro classes look like. So we sent out a survey, we did some syllabus review. There's a couple different pieces to that, but we ended up getting some data back from both syllabi and then also from surveys, which is kind of ongoing. And then ultimately what will come out of this is we wrote a abstract, which will be at AGU. So that's a little plug for everyone to come check that out. All right, and then the final piece that I worked on was this data analysis piece, and I'm not going to focus on this as much because it's not quite as interesting, I think, to a lot of people. I think it's interesting, but yeah. So like I said, I'm kind of on the engineering side of things, so it was very interesting to do data analysis in a much more qualitative way. I think I've been very strongly on the numbers side of things, and so as I was going through this, I kind of turned everything into numbers, which is fine, I think, but a little bit different. And that kind of came in with the syllabus project as well, kind of figuring out how to analyze syllabi with words instead of numbers. But the purpose of this is to kind of figure out like, what is the skill building workshop doing well? What's it not doing well? How do students feel about this? So survey responses. And so here's an example of me just kind of translating a lot of these different like survey responses, extremely likely, not very likely, into numbers, so we can do some normalized gain stuff and figure out what's actually going on. I also just wrote a lot of skeleton code. So I did some scoring code for different questions. I did some consistency tests, so Cronbach's alpha skeleton code stuff, and then some normalized gain skeleton code. So those can be used going forward, hopefully. And I've also used them with a couple different survey responses. So I can kind of just copy and paste the code, replace the column names, and then get the same kind of output for different inputs. All right, so I wanted to talk about kind of my like most valuable learning aspects of this. As I mentioned in the beginning, I've been pretty firmly in the engineering world. Prior to that, I was really firmly in the education world. And I really have been so interested on figuring out how to do both of these things. And I think the most valuable aspect of this summer for me was kind of seeing that in action over and over again. I think specifically the team I worked with has people from all of these different places. Let me check the chat. Oh, thank you. So specifically my team has people from these different places, the seismology side, the education side, bringing those two things together to kind of figure out like, how do we make this an accessible place for everybody? And how do we make sure we're doing good science and we are pulling more people into this world? So that has been awesome for me to see. It's made me a very happy scientist and a very happy educator. And it's been really inspiring for me for this year to hopefully keep one foot in the education world while being in the engineering world. So continuing efforts, I am going to try to see the skill building workshop kind of through. I'm going to continue to do the webinars on Mondays with Jillian and the rest of the team, and then as well as kind of maintaining help on that Slack. I will be going to AGU, like I mentioned, and then I'm going to continue this data analysis piece. And I just wanted to end with a big thank you to these folks on the screen. Thank you to Jillian. Thank you so much, Jillian. I really have appreciated your help this summer, and also a lot of your like validation and everything. Michael, thank you for your guidance. Kelsey, of course, Anika. And then this on the bottom is Nicole and Mike, who've also been working with the skill building workshop. And my funding information on the side if people are interested. Questions?
Lots of work, Ellie. Good job. Yes, we have time for questions. Ellie, what was the most surprising thing you think you took away this summer?
It's a great question. I think the most surprising thing for me is I think oftentimes hard numbers people, which like that is the world I've been in, is just very hard. Like these are the numbers kind of, and I've fallen prey to this in the last year. I kind of was like, oh, like qualitative analysis, that's easy, like that, you know, and it's been really hard for me. So I think that was a big surprising thing is like, I have no idea how to do this. And I don't, yeah, it's been very, I'm like, I felt almost like I'm like, need a bit of hand holding on like, how do you do a syllabus coding, a priori coding stuff with words. So that was surprising. I feel like I've been like, I know how to do data analysis, and I think it's always a bit shocking when you're like, maybe I don't actually.
It's a different side of it.
Very different side.
Awesome. Dee Dee?
So Ellie, you and I have similar backgrounds.
Yeah.
So my question to you, especially since I'm on the K-12 side of the education realm in here, is how do you see, because you have that background,
Totally.
how do you see getting kids in that age range excited to get into this field like this?
Oh, That's a great question. I think we're so lucky. Like, I think computer scientists, I think like a lot of STEM fields like aren't as exciting in a lot of ways. Like, I think that there's something so like innately human and childish about like getting excited about seeing a volcano erupting. Like, you're like, that's the coolest thing I've ever seen. And kids that age, like middle schoolers especially, I remember doing that with my middle schoolers where you could do like the simplest thing where you show a video of a volcano erupting and they're like, this is so cool, what's going on with that? And there's such a curiosity there. So I think like playing to the curiosity aspect of things. And I think there's differing views on this, but I think especially at a younger age level, the best thing you can do for students is say, you could be good at this and you could be interested in this, instead of like necessarily like the hard concepts or the hard math. It's more like this is something that might really interest you. And so, yeah, building the passion and building the confidence.
Awesome, thank you.
Any other questions for Ellie? Shelley?
One of the projects I'm working on is talking about career paths and getting middle school students interested in going in seeing themselves as a scientist, as a young scientist, and then possibility of moving on. And so I was really excited about your whole presentation because you kind of pulled the whole thing together. If there were like one thing about like your pathway, you know, your STEM identity, like when you were in K-12, did you think you'd end up as a school teacher? And then if you were being a teacher, where you're like, oh, I'm just going to go back and get this engineering degree, you know?
Yeah.
Is there like one thing, one like tip you'd like to pass on to the middle school and high school kids who are not even sure if, you know, getting out of high school is like their biggest object right now?
Yeah. I think there's a few pieces, and I think like one of them is any experience is probably good experience. So like working in any field and gaining kind of the like soft skills that aren't that soft, where yeah, that's going to be valuable in anything, and I think it's helped me so much. And then the second piece, so first would be kind of any experience is good experience. Working in a job is a good thing, and figuring out how to do that and be an effective part of a team is going to help everywhere. But the second piece is, I think something I'm like very proud of myself on is I did not pigeonhole myself. I've had a very weird career of teaching. I was a bartender. I led a gap year program in environmental education. I am now an engineering PhD student. And then my undergrad is actually in geology, so totally different. And every single professor I talked to when applying to grad school was excited about those things, and just making sure that students know how to like write about themselves, talk about themselves, sell their experiences, I think is really important. And knowing that you don't have to be the math whiz from first grade to go get an engineering PhD. I definitely wasn't. Yeah, and it's been great.
Great, those are wonderful suggestions there. Thank you.
Yeah, feel free to reach out anytime. Yeah, email me.
I might be taking you all actually up on it. Thanks.
Love it. All right. So with that, I just wanted to say thank you, not only to all of the interns who did such great work with us this summer, also their mentors for taking them on and being good leaders. Huge thank you to all of Erscope, in particular the finance and business team. Thank you all for coming and engaging with us. This little QR code will take you to an interest form. If you're interested in hosting a career intern, if you have questions about the program, you can reach out to myself or very general internships@erscope.org. So thanks, everyone. Congratulations on a successful summer. And keep in touch. We'll see you again soon. Bye-bye.